All right, so now we're going to talk about alternating series, and of course, alternating series and sort of what they sound like. They're going to, excuse me, alternate between positives and negatives. And so the sort of standard way you'll see that is you'll have -1 to a power times some other thing, and you just need to make sure that this other thing doesn't have any negatives that are creeping in, because then it could cancel out negatives and make it not alternating. And it turns out that alternating series are very easy to make converge because you have half positive, half negative. It's hard for that to go off to infinity. And so you basically just need to make sure that the terms, when you ignore the negatives, are going to zero. If those terms are going to zero and it's alternating, then it's automatically convergent. The alternating series test is never a test for divergence. So you would never say, oh, I know something diverges by the alternating series test. It's only a test for convergence. In the last video, we talked about the harmonic series. This is the alternating harmonic series. Notice the little tweak here, n plus 1 instead of n sort of in the standard format. All that does is change which term, whether the first term is positive or negative. So when n equals 1, 1 plus 1 is 2, -1 squared is positive 1. So I get 1 over 1, and then n to the, or -1 to the third will be negative, and so -1/2 plus 1/3, -1/4, and so forth. So clearly alternating. And when I sort of factor out the negative, I'm just left with 1 over n. And of course, 1 over n, as n gets big, is approaching 0. And so the terms are approaching 0. And the other piece which they'd like you to phrase, and I guess we should write it out up here, they like you to state it. If the terms are approaching 0 and the terms are decreasing in absolute value. And so sometimes you'll see it written like this, like the n plus first term is less than n, the nth term. Sometimes you'll just write it out in words. Also, you'll say not only are the terms approaching 0, but the terms are decreasing, and so that word is important, to 0 in absolute value. And so this is sort of a nice phrase to include if you're justifying it, which they always like you to do. So if the terms are decreasing to 0 in absolute value, and it's an alternating series, then you've got a convergent series by the alternating series test. Sometimes it looks a little more complicated. I've seen them throw this one in before, cosine of pi n. As we make n go up, we just flip back and forth between the two sides of the unit circle. So we get -1, 1, -1, 1, -1, 1. So this is just a tricky way of alternating. And then again, we do the same thing. We see, oh, second degree here, third degree here, these terms are going to go to 0, everything's positive, we don't have anything to worry about there. So this is an alternating series whose terms are decreasing to 0 in absolute value. And so we've checked the two boxes, right? The terms are approaching 0, the terms are decreasing, and so we can safely say that it's a convergent alternating series. That's all there is to it.